Hey everyone, thank you for coming out. My name is Deeksha Yennam. I'm a data scientist at Walmart Technology downtown. Today I'm going to talk about multilingual embeddings and how you can use them to scale your NLP models to work with different languages other than just English. Before we jump into multilingual embeddings, I want to give a very quick introduction about word embeddings. How many of you are familiar with word embeddings or use word embeddings in your work? Good. So word embeddings, as you may be aware, are vector representations of words. So basically converting words into numbers so that you can use your regular traditional data science models on natural language. So basically, vector representations are such that your semantically similar words or similar meaning words or words that appear in similar contexts in documents have similar vectors and they appear together in the vector space. So this can be useful in like document classification, semantic search, and many other NLP applications. The most common example that we see is this example right here about man, women, king, and queen. So it's basically showing you that the vector difference between man and woman is the same as the vector difference between king and queen. So man is to woman as king is to queen. So you can draw these types of analogies from vector representations. And the way we generally use word embeddings in practice is mostly through pre-trained word embeddings, such as you have word-to-vec, fast text, or glove-to-vec sort of models. You have pre-trained word embeddings that are basically a million or more words and their vector representations that have been trained on large corpora like Wikipedia or news data sets and things like that. The way we generally use, say for a document classification task is you start by collecting labeled documents. So for example, if you want to, say, build a classification model to categorize different news articles into different categories that they fall into, like sports or politics and things like that. So you start by collecting labeled documents. So each document you have a label of what it belongs to for your training data set, and then a typical pipeline would look like for, say, if you're using pre-trained word-to-vec embeddings, for each word in each of your documents, you would look up the pre-trained word embedding, and then for each document, now that you have this collection of word embeddings, you want to represent your document as a collection of numerical features, right? So now you have these word embeddings that are like building blocks, and then you take those and convert them, combine all of them for each document into a single document vector representation. You can do that in multiple ways. One of the common ways is to do element-wise mean of all the words in your document, and you get a document vector representation. You can avoid this if you're using document vector representative models as well, like doc2vec, which directly gives you an embedding for your document instead of starting with like word vectors. And then once you are at a document vector representation, you can use, basically you're now representing your documents as numbers. So you can use these vectors as features for a classification model such as logistic regression or SVM and so on. So once you have the trained model, now you have a new collection of documents which you don't know which categories they belong to. You use this classification model and you get your document vector representations and use those along with your trained model to predict the categories that they fall into. Now, the question here is, what if my data is in multiple languages? This is especially common with MNCs where you have operations in different countries, so your data need not necessarily be in English. It may be in Spanish or Chinese and so on. So imagine you have this document classification task and you have started with English, you deployed a model, and then you have another business unit in Mexico or something, and they have data in Spanish that they also want to utilize this model for. One thing you could do is start the whole process all over again, start collecting labeled documents in Spanish and train another model and do the same process, like basically solve the problem from scratch for a different business unit. Or you could use a translation service. Like, you have all these documents that you will translate into English and then use your original English classifier. But all of these solutions are very time consuming. They will introduce a lot of noise into your model, especially with the translation service. You're essentially adding another machine learning model before your original machine learning model. So now the errors are going to get multiplied, right? So, and also it's going to add a lot of cost to your project. So there are pre-trained word embeddings in different languages as well. So you get, just as you get pre-trained word embeddings for English, you also have for, I think, at least 30 other languages, you have pre-trained word-to-vec models. But the thing is, all of them are in different vector spaces. So the word that means football in English and the word that means football in Spanish may not have similar vectors. So you cannot use one single model to train both English and Spanish. The answer to that is multilingual embeddings, which basically solves this question of, when I have multiple languages, do those vectors align in the same space or not? For example, here, I have taken the example of English and Spanish. So this is using the Multilingual Universal Sentence Encoder by Google. I just created a simple plot of, I got the vectors for man, king, woman, and queen, and also the same vectors for the corresponding words in Spanish. You can see that the corresponding words are in similar vector spaces on the plot. So this means that, for example, if I have a document where people are conversing with each other and they may be switching between English and Spanish, for example. They may be talking about something and they said man and something, and then the words for king and queen were maybe in Spanish in the same document. Because the vectors are aligned properly, you can now, even if you train one single model, you will be able to capture both English and Spanish words without having to do multiple models. So there are a couple of pre-trained multilingual embeddings available. One of the first ones that I used was by Facebook. It's called Muse, Multilingual Unsupervised and Supervised Embeddings. The way they did it is they took separate embeddings for 30 different languages, and they used bilingual dictionaries to basically map vectors from one language and another language onto the same vector space such that similar words in both languages have similar vectors. And that's the way they trained it. So now you have all these vectors for 30 different languages that are aligned in one single vector space. So it's very easy to use if you're already using, say, if you have a GenSim model, word-to-vec GenSim model that you're using, you can just replace the word-to-vec embeddings file that comes for English with the multilingual one. And now, all of a sudden, you can use your same model for different languages. But the other interesting one that I have been using most is called the Multilingual Universal Sentence Encoder by Google. This is an open source model that was released, I think, around July of this year. It is a part of the broader Universal Sentence Encoder family of models that's also open source by Google. It is available as pre-trained modules on TensorFlow Hub. So these models, they take a sentence or document as an input and return a document embedding. The way they train these is for each document, they average the word vectors and then put the resulting sentence encode into a deep averaging neural network, and then they train the encoder such that it performs well on different NLP tasks like, sentiment classification or semantic retrieval or translation. In case of multilingual and universal sentence encoder, they used a bunch of different data sets of basically pairs of sentences translated by humans, or sometimes by even, I think, Google Translate, and then use that as a training data to train this sentence encoder model. It is available as a pre-trained model, so you can literally use this as a black box. For example, the code I have right here is you have to use TensorFlow, and it's a module on TensorFlow Hub. So you just load the model, and then this is a TensorFlow 2.0 example. So you just define a function called embed and say, I want to, for any list of documents that I give, I want to get a document embedding for each of those documents. So you just say model input, and then whatever documents list you have, you pass that as a parameter to your embed function. So it's as simple as that. You don't have to figure out how to train your model or even get a lot of training data. So it's very useful, but I will also say this is a little computationally expensive model. So if you're running on multiple, millions of documents, say, you'd probably need to use a GPU and set up some more advanced pipelines to make sure it's optimal and you're not wasting compute time too much. This is a language-agnostic model. It supports 16 different languages. The ones that I have used are just English and Spanish, but it also supports Chinese, Italian, Arabic, I think two different types of Chinese, Japanese, Korean, and a lot of different languages. Just as an example for the semantic similarity, this is just one single sentence. It's welcome to simple yet surprisingly powerful multilingual natural language understanding models. What people mean matters more than the language they speak, right? So we have divided this big sentence into multiple smaller phrases, and for each of those phrases, I also have the language translation into different languages. So this is in German, and this corresponds to welcome to simple yet surprisingly powerful. I think this is, I'm not sure which language this is, but anyway, you get the gist. So the embeddings that come out of the multilingual sentence encoder are normalized. So if you want to get semantic similarity, you can just do a dot product of the vectors that you have, and that gives you a cosine similarity. So if you're familiar with cosine similarity that you do in text analytics in general, it's basically just taking two vectors and seeing what is the cosine angle between them and using that as a measure for how similar your documents are. When you do that, this is the heat plot that you get. So you can see that the diagonal is the extreme red, which means that the vectors for this sentence and this sentence are extremely similar. And also you can see, for example, natural language understanding and the language they speak. Both of them have the word language in them. So you might expect that, natural language understanding will have some similarity to the vector for language they speak in Arabic. So it's not completely correlating, but also you have some slight orange here. So that's just an example of how well the semantic similarity works with universal sentence encoder. Now, in my application, I have had documents where people are talking in multiple languages and just switching over. So, they start in English, but in between they have some Spanish paragraph or something, and then they have something in English again. So when I put all my documents through the universal sentence encoder and got the document embeddings out of them, and then used that as a input to my document classification task, it worked really well for me, so I thought it may be useful. Google does provide a lot of resources on TF Hub to be able to look at, they have a lot of models on, let me show you. So tfhub.dev is where they publish all these models, and if you just click on all models, they have about, I think, 100 models, over 100 models, and you can filter by problem domain. So if you're looking for embedding related models, you can just click on that. And then you'll see a lot of these different models. The one I have used is Universal Sentence Encoder Multilingual, but they also have a question-answer specific pre-trained model as well, which is this. And then there are a bunch of other models with examples and collab notebooks. I just want to take you through this collab notebook for Universal Sentence Encoder. This is the example that I was showing you earlier, where you are just passing in sentences like this. So welcome to simple yet is, and then the German equivalent of that, and then so on. And then you can just very clearly see the similarity between these sentences is extremely high when they correlate, and very low when they don't correlate. There's also an example of creating a multilingual semantic similarity search engine within this collab notebook. I would highly encourage you to take a look into it. This is basically, they download data from a news source. Yes. So this is news sentences in multiple languages from news commentary corpus. So now we are downloading data for, I think, Arabic, Chinese, English, Russian, Spanish. And what you do is run all these sentences through the encoder and get get vectors for each of these sentences using, it's just this code. And then after that, you build an index of the semantic vectors. So now you have all these vectors for different sentences. You are building a very simple index to find, given any vector, an approximate nearest neighbor for that vector. So the implication would be that, say you're searching for the stock market fell 4 points. And if it's only in English, if you're only searching for English, it's returning sentences like this. Historically, the stock market has performed well, and things like that. So basically a semantic similarity search. But now say, because you're using this multilingual model, you're only using one model and you have multiple languages within your data set, and you'll see that it works well even for different languages. So now I'm searching for stock market fell 4 points, but in my data set I have like, I think I had Chinese, Russian, Spanish, and things like that. So it's returning sentences that are similar to the stock market fell 4 points from multiple languages. You can use this in, say, in your own work, if you have data in multiple languages and you want to do a semantic similarity search, this is exactly how it would work. You wouldn't have to do multiple models or anything like that. And here I'm trying like my own other queries. I tried for rising real estate prices, and I have no idea what these mean. I'm not conversant in any of these languages, but I searched for this, say, on Google Translate, and like for the top sentences like Chinese, Russian, everything corresponds directly to real estate. So that's how it has been useful for me. I've used mostly for document classification, but you could also use it for different other multiple NLP tasks. That's all I had, actually, and thank you so much. For me, personally, it has been a huge difference, because earlier we'd have to build models for each individual business domain separately. And now we've been able to, and especially because this is a sentence encoder, I don't even have to get word embeddings and then do a separate a whole pipeline to get a sentence embeddings out of the word embeddings and things like that. So, and also I think maybe because this has been trained specifically for performance on NLP tasks, it works really well for document classification. And I'm able to use multiple languages, like I said, and even if your document has multiple languages within a document, it still works well. Yeah, I prefer the Google one. I also use the Facebook's Muse, it's called Multilingual Unsupervised and Supervised Embeddings. It's easy to replace a GenSim model that you may already be using, but it's not as effective as the Google one.
Have you tried it on any class related classification?
I have not yet. I'm not yet, but yeah, I think this is something that I would want to explore further. Yeah, I've used the pre-trained model to build my own like document classification model, but we have not tried to like tweak the pre-trained model or anything. Does that answer your question?
Yeah, so I have a corpus that doesn't seem to work with pre-trained models like corpus. So I was wondering if you have tried to build your own.
No, I have not tried to build my own model because especially for us the concern is that we don't have as much labeled training data in general to train such a deep learning model. So we prefer using a pre-trained model that's already been trained on a large corpus.
Do you use the network or do you try to fine tune it?
No, so it was until recently, I think the Google TF Hub module did not allow you to fine tune it. It was a complete black box. But I think recently with the TensorFlow 2.2 version, they also introduced a capability to let you fine tune the model if you want to. But I haven't looked into it yet. Thank you.